The final procedure we want to learn using the normal distribution in Chapter 7 is how to use the normal distribution if you want to approximate a probability for a binomial distribution. So last chapter we talked about the binomial distribution, and let's just review what we know about that. The binomial experiment has to have four properties. The first is that you have a fixed number of trials, we call that n. Then you know the trials have to be independent, so one cannot affect another. There are two possible outcomes, success or failure, and the probability of success, or P, is the same for every trial. We also want to think about what x represents. X is a discrete random variable for the number of successes out of n trials. So your x value can only be 0, 1, 2, 3, 4, 5, and so on. We're going to be using a normal distribution, which is actually a continuous distribution, so we'll have to account for that in our steps. In order to be able to use the normal approximation for a binomial, you have to have a binomial experiment, and the value of n times p times q has to be greater than or equal to 10. That has to be true because one of the properties that was in Chapter 6 told us that if that is true, n times p times q is greater than or equal to 10, then that makes the distribution bell-shaped, which means it's approximately normal. You have to have that shape to be able to use the normal approximation. You'll use n times p for the mean, which is the same as what we did with a binomial, and you'll also use the binomial standard deviation. It's calculated by taking the square root of n times p times q. The mean and standard deviation are going to be used to change your x value, eventually, to a z value so you can find the probability. The most important step that's forgotten in these types of problems is that you have to apply a continuity correction, which sounds like it's probably more complicated than it really is. To describe why this happens, I'm just going to use a sample binomial distribution. So remember, we're starting with a discrete random variable. A binomial is discrete, and we're using a normal distribution to estimate its probability. So we're changing from a discrete value to a continuous value, which is why it's called a continuity correction. It's dealing with the fact that one is discrete, one is continuous. If you think about a binomial distribution, that would be the bar graph, the histogram that's here. I have a normal distribution shape drawn on top of it, just to get an idea of what's happening. Let's say I was looking for the probability that x is greater than or equal to 5. When I would draw my shading for that, I would line that up with the number 5, which is the center of the bar. What I end up doing, if I only find that area using my normal distribution, I actually leave out half of the bar for 5 successes. So I need to find a way to also include that extra shading for the rest of the bar. To do that, I have to remember that my bars, since they're touching, the value in the middle is halfway between 4 and 5. So this should be 4.5. The other side of that bar would be 5.5. This would be 6.5, 7.5, 8.5. So it's always some value dealing with 0.5. The continuity correction, you will always either add 0.5 or subtract 0.5, and it's going to depend on what type of inequality you have in your initial problem. So what I did was I went through all the different cases you could have and explained how you change the value of x, how you use the continuity correction. So if you have x is equal to a value, that means you would be right in the center of the bar and you just have a straight line. You can't really find the area of a straight line on the graph. So what you do is you have to include the whole bar around it, so you subtract 0.5 and add 0.5, and that stretches it out to the edges of the bar, and you find the area between those points. If you have a less than or equal to, you're going to just add 0.5 to whatever your a value is. Okay. If you have a less than, it's a little bit different because the normal distribution only knows like the less than or equal to thing. So you have to think about, like, if this was x is less than 5, that's really the same as saying it's less than or equal to 4. So I would want to subtract 0.5 in this case to get 4.5 from my original 5. If it helps you, drawing a picture might be a good idea so you can decide which way you would have to move your line to include the whole bar. So again, this is just all of the different cases. You can use this as a reference. Using that and some actual numbers in there, if you want to check that you understand how to read the previous slide. If you're finding a binomial probability for x is equal to 3, to use the normal approximation, you would actually look for the probability that you're between 2.5 and 3.5. So you would get that whole bar around 3. If you have a value x is greater than or equal to 3, you would look for the probability that you're greater than or equal to 3.5. That seems, should have said x is greater than or equal to 2.5. When it's greater than or equal to, you subtract 0.5. When it's less than 3, you also subtract 0.5 for a regular less than instead of less than or equal to. If you have a between and one is a less than or equal to, the other one is not, you would want to rewrite this probability that 1 is less than or equal to x and x is less than or equal to 2. That'll help you when you subtract 0.5 from the lower side, add 0.5 to the upper side. We're going to go through just the steps to follow for every problem. If you are using the normal approximation, I'll tell you you have to do that at the start of a problem. So your first step is to check if n times p times q is greater than 10. If it's not, you can't do anything else. You also want to calculate the mean and the standard deviation because you'll need them later. And you'll start by rewriting the question that's asked to you with a binomial probability notation. That binomial you want to change to a normal by applying the continuity correction. You'll still have an x value, but now it'll be continuous. It'll have a 0.5. You want to next change that x value to a z using the same formula we always use. Then you'll use the table in the back of your textbook to find the probability, the way that I explained in the 7.2 notes. You can check your work using StatsMate. All of the times that I ask you to do one of these problems on a test, you will be asked to do the whole thing by hand and using the standard normal distribution. You will have access to StatsMate to check your work, but if I don't see the other work, I won't be able to give you full credit. So here's a full example that we'll go through. According to the American Red Cross, 7% of the people in the United States have a blood type of O negative. We want to find the probability that in a sample of 500 people in the US, fewer than 30 have blood type O negative. We want to start by checking if n times p times q is greater than or equal to 10. N is our sample size of 500 people. P is the probability of success. Success in this case is that someone has blood type O negative, so that's 0.07 for 7%. And Q is a probability they aren't O negative, so that's 0.93. When I multiply those together, I get 32.55, which is greater than 10, which means we can use the normal approximation. Same problem. Next, I want to find the mean and the standard deviation. The mean is found by multiplying n times p. When you do that, you get 35. Standard deviation is the square root of n times p times q. I actually already calculated n times p times q in my first step, so I can just put that 32.55, take the square root, and I get 5.71. Those numbers will be needed when I eventually change to a z-score. Okay. Next thing I want to do is write my binomial probability. I'm looking for the probability of less than 30 people with blood type O negative. A regular less than sign would mean that it's the same as the probability that x is less than or equal to 29. When I have a less than or equal to, the continuity correction tells me to add 0.5. So I will be looking for the probability that x is less than or equal to 29.5. I need to change that 29.5 to a z-score. So I do 29.5 minus the mean of 35 divided by the standard deviation of 5.71 and round to 2 decimal places. So I'm really finding the probability that z is less than or equal to negative 0.96. I go back to that chart in the back of my textbook and I look for z equals negative 0.96. I know to use negative 0.96 because it's a less than or equal to, and that's what the chart tells me. You should find an area of 0.1685, which means the probability that fewer than 30 of these people have blood type O negative is 0.1685. You can double check that in StatsMate. There might be a slight difference in the probabilities because StatsMate will use more decimal places for both z and for the probability, but it should be close to 0.16 or 0.17. In class, I handed out a worksheet for finding probabilities using the standard normal distribution. That means you should not be using StatsMate to complete that worksheet. You should show me the answers that you get using the normal table in the back of your book. Then the rest of the problems are using the normal approximation to the binomial. You should show all of your work, all of those steps that I went over in the example that I just did. Your work should mirror my work there. If you have questions, you can feel free to message me on Schoology, send me an email, or come to office hours Monday. I should be there by 4:30.